Good day, everyone, again. So today we'll be doing number 7, past papers. Well, it's typically number 7. I think in the later years was number 8. That is when they used to bring what do you call this thing? When they used to bring sets as number 3. So let me just say number 7, series questions. Right? So we'll start from June 22 and go straight down. If you have any questions, let me know. I'll just pause the recording and answer them. All right. So in June 2022, they sat at an entertainment hall. The chairs are arranged in two different ways as shown in the diagram below. Arrangement L, right? These are the tables, and then arrangement M. I don't need to teach you guys. Everybody could see the pattern here, right? They're adding an extra big rectangle and then adding chairs around it. So it should look something like this. 1, 2, 3, 4, and then have the chairs around. Yeah, so it's supposed to look like something like this. And they said arrangement L, so we know it's this arrangement you're using and not the horizontal tables, right? Everybody was good with that? Right. Now, June 2022, they asked you to do part B was to solve 1, 2, and 3. I usually recommend that you solve for n first. And we know the formula if it's arithmetic sequence or if it's a geometric sequence. Now, if we look at arrangement L, we see it's going from 10 to 14 to 18. Now, to go from 10 to 14, you're adding 4, and then to go from 14 to 18, you're adding 4. So we can clearly see it's a arithmetic sequence, right? And the difference is D. So in your arithmetic sequence, you need your first term, which was 10 in this case, and you need D, which is the difference. We know the difference is 4. So I am saying that AN is equal to A1, right? A1 being 10, and D being your difference, right? A1 plus open bracket N minus 1 close bracket D. As I said, guys, this formula here is very, very important. So that is the formula you should use, right? So if we put it in, it would be 10 plus open bracket n minus 1 close bracket 4. Distribution law states that if there's a number right outside the bracket without any signs in between, it means to multiply the number outside by each term in your bracket. So 4 by n is 4n, and then 4 by minus 1 is minus 4. So that would be 10 plus 4n minus 4. When you reduce it, or not reduce it, I would say put all the like terms. So 10 minus 4 is 6, and then you have plus 4n. So you know that the formula for it is 6 plus 4n. Right? Now, if we look at for arrangement M, 10 to 16, 16 to 22, they're increasing by 6. Right? So your difference is 6, and your first term is 10. Use the formula. 10 plus open bracket n minus 1 close bracket 6. 6 by n is 6n. 6 by minus 1 is minus 6. So it would be 10 minus 6 plus 6n. We get 6n plus 4. Everybody following so far? Or am I going too fast? So now we're going to look at arrangement M, and as I said, when we go from 10 to 16 to 22, you're seeing that we have to increase by 6. So we know that the common difference for arrangement M is 6. The first term is 10, so we put that in the formula. AN, or your nth term, is equal to A1, which is the first term, plus open bracket n minus 1 close bracket D, which is your common difference. Right? A1 is 10, so your nth term is 10 plus open bracket n minus 1 close bracket 6 by 6. Right? Now, according to the law of distribution, if we have brackets and you have a number without any sign in between the brackets and the number, right? Signs being plus, minus, or division sign, right? It means to multiply. So we're going to multiply 6 by n, that's 6n, and then 6 by minus 1 is minus 6. So we have 10 plus 6n minus 6. We group like terms, meaning we cannot subtract 6n from 6, right? What we can do is subtract the 10 and the 10 and 6. So 10 minus 6 is 4, and we have plus 6n. So the formula for arrangement M is 6n plus 4. Does everyone understand? So now we're going to go onto, well, part one is pretty easy. You see you're going from your first sequence to your second, to your third, to your fourth. If you're going from your third to your fourth in arrangement L, you just add 4. So that's 18 plus 4 is 22. And for arrangement M, we see that we're adding 6. So that's 22 plus 6, which is 28. Right? Part 2 now. Now, for part 2, right, I use my formula. So the formulas I got for my nth term, right, that is what I'm going to use to solve this table right here. So first off, we are trying to find whatever n is, right, that will give you 130. So 6n plus 4 is equal to 130. Remember, n is whatever sequence it is. So we have to solve for the number. In this case, n is number of tables, right? So your number of tables, right, we have to make n the subject. So the number of tables that you would need to give your arrangement L 130 chairs. So 6n plus 4 would give you 130. You carry across the plus 4. When you carry anything across the equal sign, it will be the opposite. So the opposite of plus 4 would be minus 4. So 6n is equal to 130 minus 4. So 6n is equal to 126. Now the relationship between 6 and n is multiplication, guys. So if we multiply this, right, if you carry across, multiply by 6 over your equal sign, it will be divided by 6. So n is equal to 126 divided by 6, which is equal to 21. So we know that your number of tables is equal to 21. Does everyone understand this so far? So now, right, we know that your number of tables is equals to 21. So we can find out the number of chairs for arrangement L. We know that the formula for arrangement L is 6 plus 4n. So when n is equals to 21, we just put that in the formula. 6 plus 4, open bracket, 21, close bracket. Remember, 6 open bracket 21 close bracket means 6 multiplied by 21. So 6 by 21 is 84. So we get 6 plus 84 is equal to 90. And that is how we finish this question here. Does everyone understand this? So part C was Leon needs to arrange tables to seat 70 people. So they're telling you the number of chairs in each arrangement is 70. Right? Which of the which of the arrangements L or M will allow him to rent the least number of tables? Number of tables is this section here, and we also know that N is number of tables. So we have to find out for arrangement L and arrangement M, what is N when the number of chairs is 70. So we use the formula for arrangement L. Yes, for arrangement L is 6 plus 4n, and we know that number of chairs is 70. So we let this formula equal to 70, and you make n the subject. So we carry across 6. The opposite of plus 6 is minus 6. So you get 4n is equals to 70 minus 6, right? So 4n is equals to 64, right? You carry across, multiply by 4, because we know the relationship between 4 and n is multiplication. So n is equals to 64 divided by 4. So n is equals to 16. So we know to seat 70 people, you need 16 tables, right? Arrangement M, same thing, 6n. We use this formula that we got from part 3. 6n plus 4 is equals to 70. So 6n will be 70 minus 4, because we carry across plus 4. So 6n is equals to 66. We carry across, multiply by 6. So n is equals to 66 divided by 6. So n is equal to 11. So we know for arrangement M, the number of tables is 11. So obviously they want the least number of tables, so that would be arrangement M. Does everyone understand how to do part C? Right, so January 2022, they told you, we are seeing the sequence, so we know they asked for the fourth figure. So if this is the third figure, according to this the pattern, right? They are adding a 1, 2, 3, 4, 5, 6, 8, 7, 8. An octagon. So they're adding an octagon and then they're adding 2 squares in between. So you add 1 octagon at the end and add 2 squares at the top and bottom. So this is how it would look right here. All right, I don't need to teach you guys this. Once you recognize the pattern, right, you should be able to do these. All right, so if we look at part B, right, B, I'm not going to read all of this. Part B basically tells you to solve part 1, 2, and 3, right? Now we're going from 8 to 16 to 24. So if we look at number of dots and then the parameter of the figure, right, number of dots is increasing by 8. So we know our common difference is what, guys? 8. And your first figure in number of dots would be also 8. So you just put it in the formula that we know. A1 is 8 plus open bracket n minus 1 close bracket. Your difference is 8 as well. We know law of distribution. You multiply 8 by n and 8 by minus 1. So an is equals to 8 plus 8n minus 8, right? 8 minus 8 would cancel out. That's why you see me put a slash through it, plus 8n. So we know that the formula for number of dots is 8n, right? Where n in this figure would be a figure number, right? The parameter of your figure, right? We see it is increasing from 8 to 14, it is increasing by 6, and then 14 to 20, it is also increasing by 6. So you know that to get your next term, you have to add 6. So your parameter of your figure, right? Your difference is 6, and your first term is 8, right? So 8 plus. Right. So as I was saying, right, you put this in the formula. An is equal to 8 plus open bracket n minus 1 close bracket by, your difference is 6. So that's 6 by n is 6n and 6 by minus 1 is minus 6. So an is equal to 8 plus 6n minus 6. We group like terms, so that's 8 and minus 6. That would give you 2 plus 6n. So we know that your formula for parameter of a figure would be 6n plus 2, right? The fourth one, it is easy to find the fourth figure because we're going from the third to fourth. We know your third figure is 24, and in number of dots, you're adding 8, so that's 24 plus 8. So your number of dots for your fourth figure would be 32, and the parameter of figure, we're adding 6. So to go from your third figure, which is 20, to your fourth figure, that would be 20 plus 6, which is 26, right? Part 1 is super easy. Part 3 we already did. Now let's look at part 2. So they are saying that they want the number figure when your parameter is 86. So basically, they want to calculate n, right, when your parameter is 86. So we use the formula that we got for parameter for figure, 6n plus 2. So 6n plus 2 is 86, right? You make n the subject, right? So first off, you're going to carry across plus 2. So that's 86 minus 2, right? And then we're going to carry across multiply by 6 because the relationship between 6 and n is multiplied by 6. So 6n is equal to 64. So n would be 64 divided by 6. So n is equal to 14. So we know that our figure number is 14. So to find the number of dots would be very easy because we know that the formula for number of dots is 8 by n, where n is in figure number. So therefore, the number of dots would be 8 by 14, which is 122. Everybody good with this? Right. So if we look at part C, they ask you for any figure n is more than 1, the number of dots d is greater than the parameter p. And we could clearly see that in our table. Number of dots is always more than the parameter. Right? Determine the value of n for a figure in which the difference means the minus, between d and p is 36. So they're telling you when they subtract p from d, they're going to get 36. So we use our formulas that we have because they're telling you to solve the value of n. Which one of these have the value of n? The formula. So you have to use your formula. So that's 8n minus, guys, remember to put this in brackets, 6n plus 2, close bracket, is equal to 36. So guys, now we have So guys, please recall when I have 8n minus open bracket 6n plus 2 close bracket, right? Even though we don't see it, right? There's a 1 here. Right? It is understood that a 1 is there. So when I have to open these brackets, I have to multiply minus 1 by 6n. So that's 8n and a minus, and there's a plus in front of it. If there's no sign in front of a number, it's positive. So minus and a positive is a minus. So we get minus 6n. And then minus by plus 2, right, is a minus, and a plus is a minus. So you're going to get minus 2 here. So that is how I got 8n minus 6n minus 2 is equal to 36. Right? When I carry across minus 2 over my equal sign, I will get plus 2. 8n minus 6n, think about n like apples, or even in this case, no, think about it like apples. 8 apples minus 6 apples is 2 apples. So that's 2n is equal to 36 plus 2, right, which is 38. Now the relationship between 2 and n is multiplication. So if we were to carry across the 2 over the equal sign, it will be divide. So n is equal to 38 divided by 2. So n is equal to 19. And that would be your answer. Right? So in June 2021, the first 3 figures in the sequence shapes formed by connecting lines of unit lines are shown below. Right, so obviously you can see they're adding a house to each when we're going from one figure to the next. They're adding a house. So your fourth figure would have 4 houses. Right, I'm calling it houses, but it's a square with a triangle on top. Right, now draw the fourth figure, that's part A here. The next one is the number of lines L in each shape, and the perimeter of the shape shows a pattern. Follows a pattern, sorry. Study the pattern of number in each row and the table below and answer the following question. And answer the questions that follow. Complete the table below showing the number of lines and the perimeter of each of the figure. They're just basically telling you complete the table, right? So for number of lines, we're going from 6 to 11 to 16. That's we're increasing by 5. Yeah? So because we're increasing by 5, that means our difference is 5. And your first figure, or your first term is 6, because in number of lines. So number of lines, A1 is 6, D is equal to 5. So we just put in the formula that the nth term, or an, is equal to 6 plus open bracket n minus 1 close bracket by 5. Law of distribution states we multiply 5 by each term inside. So 5 by n would be 5n, and 5 by minus 1 would be minus 5. Right? So we group like terms. 6 minus 5 is 1, and we have plus 5. That is how I got 5n plus 1 here. All right? For parameter, we also look at the sequence. We're going from 5 to 8 to 11. It's increasing by 3, right? So your difference is 3. Your first term is 5. So you put it in the formula. A1, which is 5, plus open bracket n minus 1 close bracket by the difference, which is 3. Right? So an is equals to 5 plus, we law of distribution, multiply 3 by n and 3 by minus 1. So 3 by n is 3n, and 3 by minus 1 is minus 3. Now guys, although you're not seeing it, this 3 is positive 3, right? So when I say 3 by n, I'm talking about plus 3 by plus n. A plus and a plus is a plus, so that is how I get plus 3n, okay? And then plus 3 by minus 1 would give you a plus and a minus, so you get minus 3. So 5 plus 3n minus 3, you group like terms, that's 5 minus 3 plus 3n, so that's 3n plus 2. So that would be the formula for parameter. All right, now this one you could have found the fifth term, because from 3 to 5 you're not really increasing that much, but I just use the formula. When your figure, or n, is equal to 5, what would be your answer? That's 5 by 5 is 25 plus 1 is 26. So we know the number of lines for your fifth figure would be 26, and for parameter it would be 3 by 5 right? When your figure is 5, plus 2 is equal to 17. Now, part 2, right, they told you that the number of lines is 66 and we want to find the figure number, right? In this case, we're finding for n. So we're saying 5n plus 1 is equal to 66. That's what I did here. You make n the subject. You carry across plus 1, it'll turn to minus 1. So 5n is 66 minus 1. Then we carry across multiply by 5. That will turn to divide by 5. So n is 65 divided by 5, which is 13. So we know our figure number is 13. And if we know our figure number is 13, we can use the formula here. That's 3 by 13 is 39, right? And 39 plus 2 is 41. So you know that your parameter for your 13th figure would be 41. Do you guys understand this question? So this is part C. Write a simplified expression in terms of n for the difference. So we know difference means to subtract between the number of lines and the parameter in any figure, right? In terms of for any figure n. So they want in terms of n, so we're going to use this formula from part 3. They want the difference, that means we have to subtract, right? 5n plus 1 minus 3n plus 2, right? Now guys, remember what I said previously. If there's no number in front of your brackets, there is a 1 right here. It is understood that there's a 1. So it's minus 1 by plus 3n. That is how I got minus 3n. And then minus 1 by plus 2 is minus 2. So now I have 5n plus 1 minus 3n minus 2. So that's 5n minus 3n is 2n. And then plus 1 minus 2 is minus 1. So we got 2n minus 1. Do you guys understand this? I mean, if you don't completely understand, when we do algebra, this should be super easy. But you guys okay with when you're reading this, how to do the question? When we look at number 7, they just told you directly to go and do part E, which was complete the table. And I think that was, they just had a part B, right? So complete the row in the table below for figure 5 and figure N. So we want the fifth figure and we want n. So the first thing that we have to do is look at our sequence. So it's going from 5 to 9 to 13 to 17. That is basically we're adding 4. Not so? So 5, the difference between 5 and n is 4. Give me n. 5 and 9 is 4. 9 and 13 is 4. 13 and 17 is 4. So your fifth term would be a 4th term, which for number of dots 17 plus 4, which is equals to 21. Now, if we look at this here, right, the area of the outer largest circle, right, what we have to recognize is that these numbers, we're not looking at pi as yet. If there's no number, the question didn't have 1, right? I wrote in 1, right? Because it's understood if there's no number in front of a sign or letter, 1 is understood there, right? So 1 was understood here. So if we look at 1, 4, 9, 16, 25, right? And if you recall from number theory, right? We know that 1, 4, 9, 16, and 25 are known as squared numbers, right? And what they are squaring are the figure numbers. So 1 squared, which means 1 multiplied by 1 would give you 1. 2 squared would be 2 multiplied by 2 would give you 4. 3 squared would be 3 multiplied by 3 is 9. 4 squared would be 4 multiplied by 4 is 16. 5 squared would be 5 multiplied by 5, which is 25. And they just multiplied by pi. Now, guys, from what I just now said, you could have gotten your formula very easy. They just squared your number figure and multiplied by pi. That is how I got this formula right here, where I squared n and n squared would be n squared multiplied by pi. So my formula for area of the outer largest circle is found one time because it was because I'm looking at the pattern. Because if we look at this, it is not a geometric and it is not a arithmetic sequence, but it is a sequence where we've seen it is squared numbers. Everyone okay so far? How did I get n squared by pi? Now, if we look at area of the shaded region, I am not looking at pi, right? I'm just looking at the numbers in front, or also known as the coefficients, right? So I'm going from 1 to 3. So to go from 1 to 3, you add 2. Then to go from 3 to 2, you add 2. 3 to 5, sorry, you add 2. Then to go from 5 to 7, we add 2, right? So therefore, to get the next section, you would have to add 7 plus 2, which is 9, and just multiply it by pi. So that is how I got 9 pi. Everyone good with us so far? Right? And then this one. Now this one, guys, you have to really look at the pattern, because if you look at just 3, 6, 12, 20, 30, you'll get kind of confused. So what I did is I look at the tables here and I'm like, okay, what can I do to get 2, 6, 12, 20? My biggest number is 20. I recognize that, listen, with using all these numbers here, I recognize if I add 4 and 17, I'm not going to get 20, so it can't be I'm using my figure number and dots. Then I look at the figure number and the coefficient of area of outer circle, which is 16 pi. So I'm looking at 4 and 16, and I say, wait, 4 plus 16 will give you 20. So all right, let's just think it's 4 plus 16 by pi. We say that is for this one, but does it go for the third figure? If I add 3 and the coefficient of my area of outer larger circle, that's 3 plus 9, which is 12. So we clearly see that if you add your figure number and your area of your outer circle, the coefficient, and you just multiply it by pi, you're getting these figures in front. Does everyone understand? So for this question, you really need to think. So you would ask yourself, they would not just give you these values and just pick it out from anywhere. You have to use the information that is given in this table, right? So first off, to get a large values like this, we would never subtract. There are no bigger values here, so you can't use subtraction. You can use multiplication, but if we look at all the values here, 1 multiplied by anything here would never give you 2. Right? So you can't use subtraction. Multiplication is out of it. Division is out, because if you divide, you're going to get smaller values, right? We don't want smaller values. If we look at figure 4, so the most logical answer would be we have to add. But what are we adding to get these coefficients of total length of circumference of a circle? So this is like a trial and error to get those values, right? So I would say when you're doing that, don't do it in pen, do it in pencil so you could erase. You look at 4 and 17, there's no way 4 and 17 would give you 20. Then you look at 4 and 16 and say, well, 4 plus 16 is 20, right? And then you found the pattern, right? So you try it for the other numbers. So now you see that that would be your answer. And that would be how you get the fifth sequence would be 5 plus the coefficient of the area of outer largest circle, which is 25. So 5 plus 25 is 30, and then you multiply it by pi. Is everyone understand this? Does everyone understand this? This one was, you would have to really think about it, right? But they would never give you, just know that if they give you a section and it does not have a arithmetic sequence nor a geometric, just know that the information from this table, you must get these values. They would not just pick out values just so, right? Okay, so now we are going to find the N2. So we found this one, 5. We found the area of the shaded region for your fifth term, and we found the total length of the circumference of all circles for your fifth term. So now we're going to find for N. Now, number of dots, we could clearly see it's a arithmetic sequence, yes, right? So we know that your common difference is 4, your first term is 5, so AN would be 5 plus N minus 1 by 4. So 4 by N is 4N, 4 by minus 1 is 4, minus 4, sorry. So there's 5 minus 4 is 1, so 1 plus 4N. That is how I got this formula. This formula here, remember, it's neither arithmetic nor geometric sequence. So we looked at our coefficients. We saw that they are squared numbers. What are they squaring? They won't just pick out values from nowhere. You look at all the numbers here. You can see that the figure numbers, if you square them, you're going to get the coefficients of the area outer largest circle. So they're squaring n. So n squared by, and you just multiply by pi. Right? Now, for this one, we don't just, when you're doing this question and you're finding for n, leave out pi for now, right? Because pi is going to confuse you. Just look at your coefficients or your numbers by itself. You know your difference was 2 and your first figure was 1. So that's 1 plus open bracket n minus 1 close bracket by 2. Right? So that's an, or your n term, is 1 plus 2n minus 2. Right? So that's 2n plus 1 minus 2. So that's 2n minus 1. So that is your formula. And then whatever value you get here, you multiply by pi. So that is why I have 2n minus 1 in open and close bracket by pi. Now, guys, for this one, we saw the pattern was we're adding your figure number and your area of your outer largest circle. And we found formulas for it. So because we're adding, we literally just this. For figure number n, right, you just add n, which is your figure number, right, plus n squared, and you multiply it by pi. We did exactly what is the pattern that you're seeing here, and that is how we get n plus n squared in open and close brackets by pi, and that would be our answer for part 2. Does everyone understand this? So then part B, they said determine the value of n when the number of dots in figure n is 541. So think about it like this. They're giving you a number of dots is 541 and they want the number figure. So we're going to use the formula for n plus 1 and say that is equal to 541 and make n the subject. Carry across plus 1, it'll turn to minus 1. So 541 minus 1 is 540 and 4n is 540. So we know the relationship between 4 and n is multiplication. So if we carry across 4, multiply by 4, we divide by 4. So n is equal to 540 divided by 4. So n is equal to 135. Right? And this one, write down in terms of p and pi, the area of the largest circle for figure 3p. So they're telling you your figure is 3p. So the area of your largest circle, if we look at the formula for area of largest circle, it would be n squared by pi. We know that your figure is 3p, so that's 3p. I forgot to do this question, so I took out a picture, right? So that's 3p squared by pi. 3p squared means 3p multiplied by 3p, which is how I got 9p squared by pi, right? Now we're going to do June 2020. For June 2020, right, we didn't have to do anything. They gave, this is the question that they gave, right? If we look at this one, this is a table. They just said to complete the rows in 1, 2, and 3, right? So we know we're looking at your figure number and the number of sticks. We're going from 12 to 24 to 36 to 48. So we can clearly see we're adding 12, yeah? Now 5 would be your fourth figure for number of sticks plus 12. So 48 plus 12 is 60, right? And then your number of dots would be, you're adding 12 as well, because to go from 13 to 25, you add 12. Go from 25 to 37, you add 12. So your common difference is 12. Right, so we can see that your difference for number of dots is also 12. So we can see that both of them are arithmetic sequences. We use the formula where an is your first term, which is 12 for number of sticks. 12 plus 4 minus 1, open and close bracket, by 12. 12 by n is 12n. 12 by minus 1 is minus 12. So an would be 12 minus 12 plus 12n. So you know your formula in your n term would be 12n. Right? For number of dots, we know that the difference is 13, but your common difference, your common, not your common, your common difference is 12, yes, but your first term is 13. So we use the formula 13 plus open bracket n minus 1 close bracket by a common difference, which is 12. 12 by n is 12n, 12 by minus 1 is minus 12. So an is 13 minus 12 plus 12n, so an would be 1 plus 12n. Right? And we could probably see the trend that is going on here. To go from 12 to 13, you add 1, then 24, you add 1 to get 25, then 36 to add 1. So if you could have seen that after you did this first thing and you saw that the trend was you're adding 1 to a number of sticks, you didn't have to go through all of this. You could have just said, well, I'm adding the formula for number of sticks plus 1, right? But as if you're seeing the trend, right? Number of, so we're going to do part 2, right? They gave you the number of sticks and they want the figure number. So you're just going to say your formula, which is 12 and is equals to 156. So your relationship between 12 and n is multiplication. So if you carry across 12 over the equal sign, it will turn to divide by 12. So 156 divided by 12, n is equal to 13. Now, if you know n is equals to 13, you can use your formula here, or you can follow the trend where we know that your number of dots is just you're increasing your number of sticks by 1. So we could have just said, well, it's 156 plus 1, which is 157, or you just use this formula. 12 by n is 156, and then you add 1, which is 157. Right? Everyone okay with this question? Right? So if you look at this, June 2020, so this one did not give you a table, right? The sum of numbers of dots in 2 consecutive figures are recorded. This information for the first 3 pairs of consecutive figures are shown in the table below. Your first figure is 25, your second figure is, first figure is 13, your second figure is 25. That is from this here, right? So this is part B of this question. So your first figure, it was a number of dots, yes. So your number of dots was 13 in your first figure. Your second figure was 25, is 28. Your second figure would be 25. Your third figure would be 37, which is 62. That is for number of dots. Third figure is 37 plus your fourth figure is 49. Determine the total number of dots in figure 7 and figure 8. We do not have figure 7 and figure 8, but we're dealing with number of dots, so you just use the formula. When figure 7, for figure 7, n is equals to 7, right? Your formula is 12n plus 1, so 12 by 7 is 84, plus 1 is 85. So for figure 7, the number of dots would be 85, right? And for figure 8, n is equals to 8, so that's 12 by 8 by 1 plus 1. 12 8s are 96, plus 1 is 97. So when you add figure 7 and figure 8, you basically just add it. That's 182. I don't think this is in the homework that I gave in this section here, but I'm just doing the entirety of number 7, right? Figure n and figure n plus 1, right? This is for number of dots. We know that your formula for that is 12n plus 1. So when n is equal to n, you would still get 12n plus 1 because we know the formula is 12n plus 1. However, when n is equals to n plus 1, this is where it gets kind of, I wouldn't say confusing, but the terms kind of just a little bit confusing. So wherever you see n, you're going to put n plus 1. So it is 12n, so you're going to put 12. Remember, the relationship between 12 and n is multiplication. So that is why you see me put open bracket n plus 1, close bracket plus 1. So 12 by n is 12n, 12 by 1 is 12, and then we have 1. So that's 12n plus 13, right? 12 plus 1 is 13. And then we know that what they were doing here, they were adding it. So that would be whatever you forget when n is equal to n, and whatever you get when n is equal to n plus 1, you add it up. That's 12n plus 1 plus 12n plus 13, right? That's your group-like terms, 12n plus 12n, and then 1 plus 13. You're going to get 24n plus 14. Right now, 2019 was a little bit different, right? 2019, they tried to they try to change it up a little bit, right? Tn is the nth term, right? They give you your formula, so they want to know when n is equal to 1, or your first term. So your first term is when n is equal to 1, so T1 would be 3 by 1 squared minus 2. 1 squared is 1, so that's 3 by 1 is 3 minus 2, so T1 would be 1, right? What is the third term of the sequence? The third term, that is when n is equals to 3. So you just put it in the formula. They gave you the formula. So that would be 3, open bracket, 3 squared minus 2. 3 squared is 9. So that's 3 by 9 is 27 minus 2. So your third term would be 25. All right. All right. So I didn't do the rest because those are more algebra questions. So when we go into algebra, you guys should be able to understand these a little bit better, right? So that's why I moved on to January 2019. January 2019, we see this is the first, this is the second, and this is the third. So the fourth sequence would be 40 little houses, right? You can't see it, but it's probably how I scan it, but it's 4 little 40s, right? So now we're going to look at the table. Now this table, they just tell you to do part 1, 2, and 3. So the first thing is I won't do 1, right? I won't do part 1 because they did not give you, if they gave you 4 here, I would have done it 1 time. So the first thing, when you see a question like that, guys, always do your N2. Right? Now, with respect to this, guys, you need to look at it as each term. So when you see me say first, second, and third, right? In my first term, I'm saying 1, 2, and 3, right? So my this is increasing by 1, right? So for my first term, A1 is 1, and the difference is 1. When I say my first term, I mean these first set of figures in these addition, right? So an is equal to a1 plus n minus 1 by d, right? So a1 is 1, difference is 1, right? That's 1 plus 1 by n is 1n, 1 by 1, 1 by minus 1 is minus 1, so 1 minus 1. So an is equals to d. An is equals to n. So for this first term, the formula would be n, right? Or if you did not want to do all this and you realize that your figure number and these values here are the same, you didn't have to do all this, you could just say it was n, right? The second term, meaning in the second line, we see that 2 is a constant. So you're adding 2. So therefore your formula would have n plus 2. Right, now let's look at the third term. You see it's 2, 4, 6, right? We use the formula. We see A1 is 2, your difference is 2, so you use your formula 2 plus n minus 1 by 2. So that's 2 by n is 2, and 2 by minus 1 is 2. So that's 2 minus 2 is 0, and then we have 2n. So we know for the last term would be multiplying 2 by a figure number, which is n. So therefore the formula for this would be n plus 2 plus 2n. Does everyone understand how I got this? Sorry. So for January 2019, right? When you see things like this 1 plus 2, you treat each section as a sequence. So you'll treat 1, 2, and 3 here as your first terms, 2, 3, 2, 2, and 2 as your second sequence, 2, 4, and 6. Right? So that is what I did here. Now, if you could recognize that your first sets of numbers is actually a figure number, you can just leave this as n. So you know it's n, right? That's for your formula. N, you know 2 is constant, so it's n plus 2. And then you look at your second sequence, 2, 4, and 6. You can do your formula method where your first term is 2, your difference is 2, you put it in the formula, an is equals to 2 plus n minus 1 by 2, so that's 2 plus 2n, and 2 by minus 1 is 2, so 2 minus 2 is 0 plus 2n, so an is equals to 2n. You can do it like that. Or if you want to recognize that your figure number is being doubled, you could have just said it's 2 multiplied by a figure number. In this case, when your figure number is n, that's n plus 2 plus 2n. That is the next way to find this formula. Right, and then to find this 2, right, so we understand about n plus 2 plus 2n, and then your parameter 5, 8, and 11, right, you see that it's a clear arithmetic sequence, so you can use the formula an is equals to a1 plus n minus 1 by the difference, right? 5 is your first term, difference is 3, so you use your formula an is equals to 5 plus n minus 1 by 3, and then we have 5 minus 3 plus 3n, so it's 2 plus 3n, so that would be your n sequence for parameter or your formula, right? And then part 2, right, so they told you your parameter is 65, so we're going to find out for n, right, or your figure number. So 2 plus 3n is equals to 65. 3n is equals to 65 minus 2. If you carry across plus 2 over the equal sign, it'll turn to minus. Right, so 3n is equals to 63. So n would be 63 divided by 3, which is equals to 21. So you know your figure number is 21. So now it is easy, yes? Right, so we got your figure number to be 21. We know the formula for number of outer length of number of outer lines of unit length, right? Do not add it up, because if you add it up, you're going to get 65, right? We have to leave it in this form. So we know your first term is your figure number, your second term is always 2, and your third term is 2 multiplied by a figure number, which is 42. So it would be 21 plus 2 plus 42, and that is how you got this here, right? Now, if you add it up, you're going to get 65, right? Did you get 65? So remember, we have to, but you had 21 plus 2 plus 42, and you put equals to 65. Yeah, but no, this would be, you would still get your mark since you have 21 plus 2 plus 42, right? Show that no figure can have a parameter of 100 units, right? So they're telling you this is supposed to be equal to 100. They said no figure. Now 2 plus 3n is equals to 100. You carry across plus 2 will turn into minus 2. So 3n is equal to 100 minus 2. So 3n is 98. So n would be 98 divided by 3. If you divide 98 divided by 3, you're going to get 22 and 2/3. Your figure number can only be whole numbers. So n needs to be a whole number, therefore n cannot be 22 and 2/3, hence the parameter of 100 units do not exist. I don't even know why I cross out exists and I put exists again, but yeah. Right, they said show that no figure. So first off, if they tell you your parameter is 100 units, you have to find for n, right? So wait, what is that way noise? All right, right. So when you look at this question, all right, so now we're going on to June 2018. So this one we can clearly see they're adding 2 little blocks. So your fourth figure would look something like this, or your third figure with 2 blocks here, right? Yeah, this is how it would look. Right, guys, when you're drawing this, you don't really need to make it perfect, especially during exams. So you don't need to look at the shape, just draw something relatively correct, right? Make sure it squares. Now they said to complete the table, right? We're going from 3 to 5, 5 to 7. We're adding 2, so you know your difference is 2. Your first figure is 3, right? Therefore, your fourth figure would be your third figure for number of squares plus 2. So that's 7 plus 2 is 9. When we're going from 8 to 12, 12 to 16, we're adding 4. Therefore, your common difference is 4. So we can clearly see that to go from your third figure to your fourth, it's 16 plus 4, which is 20. Right? So number of squares, right? The formula for number of squares. So after I did this first one, I'm going to the third one. Right? That's A1 is 3, difference is 2. Right? So an is equal to 3 plus n minus 1 by 2. 2 by n is 2n, 2 by minus 1 is minus 2. So that's an is equals to 3 plus 2n minus 2. 3 minus 2 is 1 plus 2n. So that is the formula. 2n plus 1 and 1 plus 2n is the same thing, right? I just rearranged it. Right, for parameter of figure, you have your differences 4 and A1 is 8. Right, that's 8 plus n minus 1 by 4. 4 by n is 4n. 4 by minus 1 is 4. So an is equals to 8 minus 4 plus 4n. So you're going to get 4n plus 4. Right, now we're going to try to, for part 2, they're telling you to find your figure number when the number of squares is 43. So you're going to use your formula, say it is equals to 43, right? And find n. So that is 2n plus 1 is 43. You carry across 1 plus 1 will turn to minus 1. So 2n is 43 minus 1. So 2n is 42. N is equals to 42 divided by 2. So n is equal to 21, or your figure number is 21. Right? If you know your figure number is 21, you can use this formula to find the parameter of a figure. That's 4 by your figure number, which is 21, plus 4, so that's 84, plus 4 is 88. So far, so good? Now, this one, determine the relationship between the squares and the parameter of a square. So, this one, you need to see, you need to ask yourself, and I wrote down what you have to, what, you look at n, what would you have to do to get from 2n to 4n? What you have to do? You have to multiply by 2. So if I multiply 2 by 2n plus 1, so what do you do to s, which is 2n plus 1, to get 4n plus 4? We look at the n's first. You multiply by 2. You can't just multiply 2 by 2n. You have to multiply 2 by 2n plus 1. 2 by 2n plus 1. 2 by 2 is 4n. 4n plus 2. Right? Now, what are you going to do to go from 4n plus 2 to get 4n plus 4? That is the difference between 4n plus 4 and 4n plus 2. The difference between these two is plus 2. So that is why I have here 2n plus 1, right? And then you're adding 2 to that. We know 2n plus 1 is s, right? So that is why I have 2s. So I'm multiplying 2 by s, which is 2n plus 1, plus 2, which is the constant that we're adding to get p. Right? We multiply, yeah. So therefore, we multiply 2 by 2n plus 1. We know 2n plus 1 is s. And then we add 2. So that is how I got 2s plus 2 is equal to p. Guys, don't worry about this too much, so much. When we do algebra for the rest of the year, you should be able to understand this. Right, so January 2018, let's go ahead. Figure 4, you see you're adding 2 rectangles, so it will be figure 3. Draw exactly figure 3 and you add 2 triangles. Right, this one, study the pattern. I'm not even going to read it because it's just telling you that the table is a pattern. Right, and they told you to complete row 1, 2, 3, and 4. Right, so now we're going from 2 to 7 to 11. We see from 3 to 7, 3 to 7 you're adding 4, and then 7 to 11 you're adding 4. So your fourth figure would be 11 plus 4, which is 15. Right, now your parameter of a figure would be, if we look at this, so this is, I could either find the formulas like this, or you can look at the trend. 0, 1, 2, right? You're looking at, you know what? We'll use the formula. You choose 0, 1, 2 as your first term, 1, 2, 3 as a second term, 2, 2, 2 as your third term, 3, 5, 7 as your fourth term. So you'll see me saying terms, right? So your first term is 0, 1, 2, 0, 1, and 2. So your first term is 0 and your difference is 1. So an would be 0 plus n by minus 1 by 1. So when we multiply 1 by n is n and 1 by minus 1 is 1. So we know that the formula for your first term is n minus 1, right? Then you see 1, 2, and 3. If you can recognize that 1, 2, and 3 is actually a figure number, you don't need to do all this, but we'll do it, right? A1 is 1, your difference is 1 to go from one term to the next. So an would be 1 plus n minus 1 by 1, right? 1 by n is 1n, 1 by minus 1 is 1. So an is 1 minus 1 plus n, so an is equals to n, right? Your third term is a constant of 2's, right? So 2 is the constant in that. And your fourth term, you're going from 3 to 5 to 7. 3 to 5 to 7, you're adding 2, right? So an is equals to 3, which is the first term, plus n minus 1 by 2. So 2 by n is 2n, 2 by minus 1 is 2. So an is equals to 3 plus 2n minus 2. So an is equals to 2n plus 1. That is your fourth term, right? So that would be your formulas for here. Now the formulas for number of toothpicks. Your first term is 3, your difference is 4. You use your formula, an is equals to 3 plus n minus 1 by 4, right? So an is equals to 4n plus 3 minus 4, so that's 4n minus 1, so that is the formula here. Right, now that you found out the formula for the 2, you can find out this term, which is, if your figure number is 4, that's 4 minus 1, so your first term is 3, your second figure would be 4, which is a figure number, plus 2, and when you add them all up, you're going to get 9. 4 plus 3 plus 2 is 9, so this would be, this is your answer, 3 plus 4 plus 2 is equal to 9, okay? For number part 2, right, you can recognize, instead of going back at the formula, we know that your second term is actually a figure number, so you can do that. That's why I underline 20. 20 is a figure number, so you can do that. You know the formula, 4n minus 1, so you say 4 by 20 is 80, 80 minus 1 is 79, right? For this one, you'll have to use your formula, right? You want to find the number of figures. What did I do here? Right. Yeah, this is, yeah. For part 3, you know that your number of toothpicks is 127, so that's 4n minus 1 is 127. You carry across 1, so that's 4n is 127 plus 1. So 4n is equals to 128. N is 128 divided by 4. When you carry across, multiply by 4, it'll turn to divide by 4. So n is equals to 32. If you know n is equals to 32, it is very easy to use this formula. You know your first term is your figure number minus 1, so it'll 31. That's 32 minus 1 is 31. Then your second figure is your figure number. Your second term is your figure number, which is 32, plus 2, 31 plus 32 plus 2 is 65, so you know that your answer is 65, and that is how you would do this question. Does everybody understand this question? I know it's a lot. 2017. Number 8, we see that we are adding the number of figures, we're adding the balls at the end, right? So this, for the fifth figure, would have 5 balls at the last stage, and then you're going to have 4, then 3, then 2, then 1. So this is how your fifth figure would look, right? Then they ask you for how many dots would be in your sixth figure. So what you guys need to do is write out your number of dots. I wrote a table so you can see. Figure 1 has 1 dot. Figure 2 has 3 because I counted 3 here. Right? Figure 3 has 6, figure 4 has 10, figure 5 has 15. We can clearly see, to get your next figure, they're adding this number to your figure number, not so? So you're adding the number of dots on your figure plus your figure number. So figure number that you're trying to figure out, so if you're trying to find out figure 5, it would be 5 plus how much dots in your previous figure, which would be 10. So 5 plus 10 is 15. So what they're doing is 1 plus 1 is 2. right? And then 3 plus 3 is 6. Then 4 plus 6 is 10. You guys seeing the trend? 5 plus 10 is 15. So a six figure would be 6 plus 15, which is 21. Does everyone see that? All right. So the table below refers to the figure and the number of dots in each table. Study the pattern shown. So they give you a formula here already. So we're going 1, 2, 3. They want 11 and n. So we see a half is constant. We see 1, 2, and 3 is actually a figure number. Then we have 1, 2, and 3 is also a figure number, and 1 is a constant. So it is very easy to get your formula. When n is equal to, when your figure number is n, that's a half, multiply by, you see, it's your figure number, so it will be multiplied by n, multiply by, you see, it's a figure number. This is supposed to be divide. I don't know why I have plus. No, it's supposed to be plus. It's not divide, it's plus. So it's n plus 1. So it's a half multiplied by n multiplied by n plus 1. I did this. The first term is a half, which is a constant. Your second term is figure number, is the figure number. Your third term is a figure number. Your fourth term, 1 is a constant. A half multiply here. That's supposed to be plus. So your n term would be a half multiplied by n multiplied by n plus 1. So your figure number, when it's 11, would be a half by 11 by 11 plus 1. When you multiply this out, you're going to get this answer. So you can do that as well, right? For a number of dots, right, what I did was I just reduced this. So I multiply n by n, which is n squared, and n by 1 is n. So I have a half multiplied by n squared plus n. So you can leave it as this, a half, open bracket, n squared plus n, or you multiply a half by this, so a half by n squared. So it would be n squared plus n all over 2, right? You can do that. Or leave it. I like to leave it in the brackets, right? Now, complete the row which corresponds to the 11th figure. We already did that. Determine which figure in the sequence have 210. Now, for this one, you have to kind of think about it because it's not something that you need to solve for and make n the subject. Unless yeah, you really need to think about it. No, yeah, you'll need to think about it, right? So we want to know what is n when a half by n squared plus n is equals to 210, right? So I made the subject where I carried across multiply by half, that would be divide by half. So n squared plus n, also known as n, open bracket, n plus 1. I think you need to know algebra for this, but we'll do it. N squared plus 1 is, you look at what they have in common, they have n. So n divided by n squared is n, and n divided by n is 1. So that is how I got my brackets to have n plus 1. So n, open bracket, n plus 1 is equals to 420. When we carry across the half, it would be divided by half, and then that would turn to multiply by 2. So it's 420. Now, when you look at this, you think about, they give you look at 420. What number, when you multiply twice, would give you your closest to 420? 400. 420, sorry. Two numbers that you can multiply. If you multiply 10 by 10, you get 100. So we would not use n as 10. Then you say, well, let's try 11, then 12, then 13. This is trial and error. But the closest number would be 20 because 20 by 20 is 400, right? So we put, say, well, let n equals to 20. So 20, open bracket, 20. 20 by 20 is 400, or actually, no. Let's add the brackets first. 20 plus 1 is 21, and 20 by 21 is 420. So therefore, n is 20. This one is through trial and error. Usually we they don't bring questions like this. Was this a June question? I don't know how come they try to bring something different. Right? Write a simplified algebraic expression, the number of dots in figure n. So we're trying to number of dots is this. We're trying to express this in lowest term. So, n, n squared by n all over 2, you factorize this. As I say algebra, when we factorize this, you ask yourself, what could go into n squared and what could go into n at the same time? N. So n is outside the bracket. So n by n multiplied by what would give you n squared? N multiplied by n plus n multiplied by what would give you n? N multiplied by 1. So it's n plus 1 in brackets by n all over 2. All right? And you can leave it as this, or they said simplify it. So divide by 2 means multiply by 1 over 1 a half. So it would be a half n open bracket n plus 1. Any one of these guys should be good. Huh? If you have n squared plus n all over 2, that should give you a mark. Show that there's no diagram that is exactly 1,000. Right? So same thing that we did here. We say a half n n plus 1. N by n plus 1 is equal to 1,000. We carry across a half over the equal sign. That is divide by a half. So that's 1,000 multiplied by 2. Now, same thing that we're going to do. You're going to ask yourself, n multiplied by n, what is the closest number that could give you 2,000? What two numbers? Let's go. 900 multiplied by 900. No, that's too much. Let's say 40 multiplied by 40. That's 1,600. Let's try 50. 50 multiplied by 50. That's 25. Now, guys, but I don't even want to go through this question because I feel like you're getting confused. For this question here, you would have to write a statement that n has to be a whole number, and there's no whole number that would give you a number. There's no whole number that would give you an answer for 2,000. So n is not equal to a whole number, right? That's what you would say. N is not equal to a whole number. And because the number of diagrams need to be a whole number, that is how you would show that no diagram has exactly 1,000 dots. Right, for June 2017, right, we see that they're adding 1 on each side. So it would have 3 going up, 3 going across, 3 going from the middle. 1, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Right, so it would look like this. That's their draw a figure. Then they say to solve this. Right, so 1 to 5, and then 5 to 9, you add in 4. So the fourth figure would be 9 plus 4, which is 13. Then 4 to 12 and 12 to 20, you add in 8. So you know your common difference is 8. So to go from your third to fourth is 20 plus 8, which is 28. Right? Number 2 and number 3, well, part 3, no, you wouldn't be able to do 1, 2, no, you wouldn't be able to do 2 and 3 without finding the formula. So, same thing for number of units of squares. A1 is 1, difference is 4, right? You use a formula 1 plus n minus 1 by common difference of 4. 4 by n is 4n, 4 by minus 1 is 4. 1 plus 4n minus 4, that would be 4n minus 3. That is your formula for this here. For parameter of a figure, right, would be right, so so we got the formula for unit squares, which is 4n minus 3, and we got the formula for parameter of a figure, which is 8n minus 4. So we can find out for when your number of unit squares is 45, we use the formula, right? 4n minus 3 is equals to 45. You make any subject carry across minus 3, that would be plus 3. So 4n is equals to 48. N is equals to 48 divided by 4. So n is equals to 12. Right? When you know your figure number is 12, it is easy to find the parameter of a figure. We're using the formula. That's 8 by 12 minus 4. You'll get 92. Right? And now you can do part 3. You have the formula. You have n, or your figure number, to be 30. That's 4 by 30 is 120. 120 minus 3 is 107. Not 100. And hold on. Let me, tools. I don't know why I put add text. Put this here. It's not 113, guys. It is, this is equal, this is equal to 117. Okay, guys, not 113. Yeah, because 120 minus 3 is 117, not 113. And 240 minus 4 is 236. Everyone good so far? Yeah? All right, let's go to June 2016, right? You can see for each branch they're adding 2. So for this branch, it would look something like this. It's kind of scratchy, but this branch here would have 2, 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 and this branch here would have 2, right? Something that looks like this. It does not need to be so neatly done, right? June 2016, they asked you to complete the table. Right, this one is a little bit different. Right, this is not algebra, nor is it geometric sequence, right? So this one you have to really look at the trend, right? No, you have to look at the relationship between K and S. K and S. What would you do to go from K to S? What would you have to do, guys? You can either multiply by 2, but if you add 2, right? If you add 2 for the first figure, you say, all right, well, to go from 1 to 3, you can add 2. So let's add 2. But that only works for the first one. 3 plus 2 is 5. It does not work for the second one. So you know adding 2 is out of this question, right? The next thing is, well, we're going from a smaller number to a bigger number. So you can only multiply or add. So the next thing is, well, how do we go from 1 to 3? What do we have to multiply by, right? You want a constant whole number. So we say, well, let's multiply by 2. 1 plus 2 is 2, and then 2 plus 1 is 3, right? So we say, okay, that works for the first one. Now let's see, let me write this down because I feel like this might confuse you guys. So when you're doing this question, right, you look at the relationship between K and S, right? So the first figure was 1 and they're going to 3. And then you're going from 3, you're going to 7. And then 7, you're going to 50. We're obviously increasing in value. So we say, well, for the first figure, if you add 2 here, you're getting 3, yes, but you have to add 2 to all of them to get these values. 3 plus 2 is not a 3 plus 2 would not give you 7. So you say, well, addition of 2 does not work. Right? So the next thing is you'll have to multiply. But we know 1 multiplied by 3 divided. Right? We know if we're multiplying, multiply by 3. 1 multiplied by 3 is 3, but 3 multiplied by 3 here would not give you 7. So we know it is not multiplying by, this is 3. So you can't multiply by 3. So now we have to think, well, what is a number less than 3? 2. So let's multiply 1 by 2. 1 by 2 is 2, and 2 plus what would give you 3? Plus 1. So let's do that throughout. We say 2 plus, multiply this figure by 2 and then you add 1. So 3 plus multiplied by 2 is 6 and 6 plus 1 is 7. Then 7 multiplied by 2 is 14 and 14 plus 1 is 15. So we can clearly see what we are doing is we're multiplying 2 by k and then you add in 1. So that would be your formula where you say 2 multiplied by k, which is this figure. 2 by k is 2 by k, and then you add 1 to get your number of strings. So that would be your formula for this. So you're saying k is being doubled and then 1 is added, so you get that, right? So you can find everything. Your fourth figure here would be 2k. Oh, no. You wouldn't be able to do this one as yet. You'll just be able to do this one right here. Right? You'll be able to do part 2. Part 2 is you're trying to find for k. You can find for k here, where you know that 255 is equal to 2k plus 1. So 2k you carry across plus 1 over the equal sign. That will be 254. So 2k is equal to 254. So k is 254 divided by 2. So k is 127. And that would be your answer, right, for this one. However, we need to get a formula. This question is a little bit tricky. There is no formula that you need to learn. You need to try to look at the relationship. Right, so we're going from 1 to 1. Right, remember we have to increase in value. So to go from 1 to 1, so we can't add anything, nor can we subtract. So the only other thing that you have to do is find the power of. That is the only way that you can increase, right? So you say, well, the power of what? 1 to the power of something, but 1 to the power of anything would give you 1. But 2 to the power of, so this is how your train of mind should go. First off, you ask yourself, how do we go from one number to a next number? We're increasing. So to increase, there are a few things that you can do. You can add, you can multiply, and you can find the power of. To find the power of, that is how you would increase. Right? Now, if you're going from n to k, right? Let's look at this. If you're going from n to k, you say, well, to increase a number, we add. But anything that you add 1 to anything, you're going to get something bigger, right? So you would not get 1. So we know addition is out. Multiplication, same thing. You know multiplication would be out. So, well, we look at power of. Now, you say 1 to, let's say we're saying n to the power of any number would give you 1, yes. But then you look at the second section and you say, well, 2 to the power of 2 would give you 4. And yes, you can minus 1 to get 3. So we look at the second one and you say, well, we're looking at powers. So we say 1 to the power of 1 is equal to 1. But that has to work for 2. 2 to the power of 1 would give you 2. And you just add 1 here. But if you're adding 1 to the second term, you have to add 1 here. So you know that this does not work. So now what you have to do is change your train of thought and say, well, let's say that my power is n. So I'm saying my constant would be 2. We see 2 to the power of something would work. 2 to the power of 2 is equals to 4. And now we could subtract 1. So now this is how your train of thought would go. Well, 2 to the power of n minus 1, which should be the formula for this. This one is a little bit tricky, guys. You have to really, really think, right? So when we look at this, when n is equals to 4, no, yeah. So when n is equals to 2 and k is 3, right? So k is equals to 2 to the power of 2 minus 1. You see you get 3. And you look at this when n is equal to 3, k is 7. So we try that 2 to the power of 3. This is just trial and error for this question. 2 to the power of 3 minus 1. 2 to the power of 3 is 8. 8 minus 1 is 7. So we can clearly see it's 2, which is a constant, to the power of n, which is what they gave you here, minus 1 would give you your formula, right? Now, if you find that out, you can also, you write the formula. I wrote the formula here just for me to see, right? So now that we know that k is 127, we make 127 the subject of the formula in this, right? So when, right, so 2 to the power of n minus 1 is equal to 127, right? So you make n the subject. So that's 127 plus 1 is 128. And you use your calculator, trial and error, guys. 2 to the power of each number. 2 to the power of, we'll try a big number first. You say 2 to the power of, let's say 10. 2 to the power of 10 is 1024. So it cannot be, n cannot be more than 10. So you keep on doing. You say 2 to the power of 9. 2 to the power of 9 is 512. No, that's not 128. Then you say 2 to the power of 8. That is 256. Yeah, but we still need to go. 2 to the power of 7 is 128. So you know, for this question is more trial and error. So 2 to the power of n, you use a calculator. Say 2 to the power of 10. Right? So you know, you choose a number, a large number, and then you work yourself backwards to get 128. So n is equals to 7. That is how you would get 7 in this question. Right? Now, when n is equals to 10, you have your formula. That's 2 to the power of 10 minus 1. You use your calculator. Right? 2 to the power of 10 is 1024 minus 1 is 1023. Right? And then you know the formula for S, which is number of strings, would be 2k plus 1. That's 2 to the power of whatever answer you get for k plus 1, and you'll get 2047. This question, guys, I will send it to you guys. Just look at it and really try to understand for yourself here and just look back at the video. That question there wasn't any kind of formula that you could use. It was trial and error, right? Now for January 2016, we went back to our normal little tables, right? The ask for the fourth figure, it would be four kites, right? And then we go from here, from 4 to 7, 7 to 10, we see that we're adding 3. So your fourth figure would be 10 plus 3. And then 6 to 11, 11 to 16, we're adding 5. So your fourth figure would be 16 plus 5, which is 21, right? We can't find out any of these unless we find the formula. So you know your first figure is 4, your difference is 3. So A1 is equals to n minus 1 by d. So A1 is 4, your difference is 3. That would be 4 plus 3n minus 3. 4 minus 3 is 1. So an, or your n term, would be 3n plus 1. Right? And for number of lines, you know your difference is 5, and your first figure is 6. That's 6 plus n minus 1 by 5. 5 by n is 5, and 5 by minus 1 is 5. So that's 6 minus 5 is 1 plus 5n. So you know that is the formula. Now that you know those formulas, this should be easy. When n is equals to 10, right, you say 3 by 10 plus 1 is 31. And then when n is equals to 10 here, you say 5 by n, which is 10. 5 tens are 50 plus 1 is 51. And now you have this here. You want to find out the figure number, right? So you say let 3n plus 1 equals to 49. You make n the subject. You carry across 1, that's 49 minus 1. 3n is 48, n would be 48 divided by 3, so 16. Now that we find what is your figure number, you can use this formula to find the number of lines, which would be 5 by 16 plus 1, which is 80. and that would be an answer. For June 2015, they're adding a next section of triangles here. This is how it would look, right? Yeah, right. June 2015, you're just going to add a next section of triangles, right? This one, we know that these numbers here are squared numbers. They are squaring your figure number, so it would be 1 squared, 2 squared, 3 squared, 4 squared, right? And if you look at this, you see 3 is constant. Your second term is actually a figure number. Your third term is a figure number. 1 is constant, right? And then your answer here is just when you multiply it out, right? Yeah, when you multiply it out. So when you have 144, what number by what number will give you 144? We know 12. Then you can use your formula. That's 3 multiplied by a figure number, which is 12, multiplied by 12 plus 1 over 2. You use your calculator, you'll get 234. For 25, if your figure number is 25, that's 25 squared. For number of unit triangles, that's 625. And then for number of unit sides would be 3, which is constant, by 25, which is a figure number, by 25, which is a figure number, plus 1, which is a constant, all divided by 2, and you'll get 975, and this is your formula. Right, for January 2015, they're adding boxes, right? So it's going to look something like this. Right, for this one, super easy. We're going to 3 to 8 to 11. You're adding 3, so your fourth term would be 11 plus 3, which is 14. However, before you do part 2 and part 3, you need to find out your formula. Your first term is 5, your difference is 3, so this would be your formula. 5 plus n minus 1 by 3, that's 3 by n is 3, and 3 by minus 1 is 3, so that's 5 plus 3n minus 3, so that's 3n plus 2, right, would be your formula, right? So it's very easy to do the rest. If n is equals to 10, that's 3 by 10 is 30, plus 2 is 32, and when your number of squares is 50, right, you use this formula, you say this formula is equals to 50, and you find for n, right? When you find for n, right, you say, you carry across 2, that's minus 2, so 50 minus 2 is 48, 3n is 48, so n would be 48 divided by 3, which is n is equals to 16. Right, this one, you're seeing that, hi, right, number 8, this is June 2014, right? Your figure number, you see that they just adding an additional space. So your fourth figure, I did not use my ruler for this, right? But it's supposed to have 4 spaces, 1, 2, 3, 4 on each side. So 1, 2, 3, 4, right? 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and it's supposed to have a 1, 2, 3, 4. It's supposed to look something like this. Right, complete the table below by inserting the missing information at the root numbers. We see it's going from 5 to 10 to 15, right? They didn't even ask for a formula, but we know these are multiples of 5. So 1 by 5 would be 5, 2 by 5 is 10, 3 by 5 is 15. So when a figure f is 5, so that's 5 by 5 would be 25. When it's 6 by 5 is 30. So you find this. Your formula, right, what they did was your first term 5 is constant, 2, 3, 4. They're actually adding your figure number to 1, and then they're minusing 5, right? So that would be 5. So your fifth term would be 5, which is a constant, multiplied by your second term is your figure number, which is 5, plus 1, which is 6, and then you're minusing 5 because 5 is also a constant, right? And for figure 6, it would be 5 multiplied by 6 plus 1 is 7 minus 5, and then you get those answers. Write an expression in F for the number of dots used for the F figure. They're just telling you to find a formula for number of dots. Here, we know it would be for your F figure, usually we do an nth figure, so for F figure it would be F multiplied by 5, right? which figure in the sequence contains 145 blocks? We know that your formula is F4, 5F, so we want to know what is F equal to. So you carry across 5, multiply by 5, it will be divided by 5, so your F figure would be 29. Right, so for January 2014, right, they are adding, I believe, 2 sets of squares, right? So it would look something like this, right? Part B, we're going from 4 to 8 to 12, we're adding 4, so your fourth figure would be 12 plus 4, which is 16. We're going from 6 to 10 to 14, we're also adding 4, so your third figure, which is 14 plus 4 is 18, will give you your fourth figure. Right, to find your n sequence, we know your first term is 4, your difference is 4, so therefore, yeah, the formula would be 4 plus n minus 4 by 4. That is 4 minus 4 would be 0. So your formula is 4n. For number of dots, you know your first term is 6. Your difference is 4. 6 plus n minus 1 by 4. 4 by n is 4n. 4 by minus 1 is minus 4. So it'll be 4n plus 6 minus 4 is 4n minus 2. Right, so if we want to find part 2, we know the formula. If n is equals to 10, that's 4 by 10 is 40. And if n is equals to 10 for number of dots, that's 4 by n is 40 plus 2 is 42. Right? Then if we're going to do part 3, you're finding for n, 4, n is equals to 64. So n is equals to 64 divided by 4, which is 16. Right? For this one, you'll do, if n is equals to 16, that's 4 by 16 plus 2, and that will give you 66. Right, guys? This one, for each diagram, you have a cube. So you'll have 4 diagrams here. Diagram 4 would have 4 cubes. Right? For this one, we're adding 12 to 20 to 28. We're adding 8. So your fourth term would be 28 plus 8 is 36. For number of balls, we're adding, increasing by 4, 8 to 12 and 12 to 16. So your fourth term would be 16 plus 4. Right, I found the formula to find my 20th term, right? So A1 is 12 for number of y's, and your difference is 8. So your AN, or your formula, your n term, would be 12 plus n minus 1 by 8. 8 by n is 8n. 8 by minus 1 is 8. So that's 12 plus 8n minus 8. So that's 8n plus 4, right? And if you know the formula, when n is equals to 20, n by 8 by 20 is 160 plus 4. So therefore, the number of wires would be 164. Number of balls is an arithmetic sequence. So you say A1 would be, sorry, not A1, AN would be 8 plus n minus 1 by 4. 4 by n is 4n. 4 by minus 1 is 4. So AN is 4n plus 4 plus 8 minus 4. So 4n is equal, AN is 4n plus 4. And when n is equals to 20, that's 4 by 20 plus 4 is 84. Write the rules in which this one they say write the rules in which that is just the formula that you would use. So for W, it would be 8n plus 4, which is what we got here. And for B, the formula would be 4n plus 4, and that would be here. Right, I just have 2 more years, guys. Just think with me. Right, my fourth figure would look something like this. I didn't have space, although they gave you an answer sheet. I didn't print out the answer sheet, so I didn't do it. I just did it right here. Right, these are the patterns. We're seeing squared numbers. I did something like this. So we know that we're squaring the figure number. So when we have 100, what multiplied by what would give you 100? You know it's 10. Right, and if we look at this, 2 is constant, 3, the second term is actually a figure number. Your third term is 1, and you just add it up. So it's 2 multiplied by a figure number plus 1. So that is your formula right here. So when they ask for a 10th term, it would be 2 multiplied by 10 plus 1, which is 21. Right? So you have your formula. Now, guys, for that is part 2, and that is part 4. You know the area of a triangle is, and you're squaring the number, you're squaring your figure. So that is how I got these 2 formulas, right? Well, I did this as a next term, 3, 5, 7, 9. I see it's increasing by 2, right? So I had A1 is 3, a difference is 2. So that's 3 plus n minus 1 by 2. 2 by n is 2n. 2 by minus 1 is 2. So that's 2n plus 3 minus 2, which is 2n plus 1. That is how I got this formula here. Right? This one would be super easy. When your figure number is 20, your area of a triangle would be 20 by 20, which is 400, and you have your formula here. When n is equals to 20, it's 2 by 20 plus 1, which is equals to 41, and that would be your answer. Right? January 2014, they just add in a box with a little x. That would be figure 4. For this one, right, if we look at the formula, you see, this is your figure number multiplied by 6 by a constant, multiplied by your last term. Here, they are minusing your figure number minus 1. So therefore, or you're decreasing it. So therefore, your fourth term would be 4 multiplied by 6 minus 3. And this you're increasing by 5. So you would plus 5. So 16 plus 5 is 21. This one you can have a formula. Did they ask you for the formula? No. Right, your 10 term would be 10 multiplied by 6, which is constant, minus 10 minus 1 is 9. That is how I got this. And when you multiply that out, no. When you multiply it out, then you need to get the formula. You need to get the arithmetic sequence, the nth sequence to do this part here. Right, so what you do, you know your first term is 6, your difference is 5, you put it in the formula for arithmetic sequence at 6 plus n minus 1 by 5, 5 by n is 5n, 5 by minus 1 is 5, that's 6 minus 5 plus 5n, so you get 1 plus 5n is the formula, so when n is equals to 10, that's 5 by 10 is 50 plus 1 is 51, that is how I got this here. Which figure in the sequence would use 106 straws? Right, so they tell you number of straws here. So they want the figure number. You use your formula from above. That's 5n plus 1 is 106. You make n the subject. You get n is equals to 21. Right, the pattern, they ask you the nth pattern. Right, we found this. That is pattern D. But we had to use that to get this here. Right, guys? Okay, I think this is the last one. Last one, right? This one would have 4 little squares. I apologize how this is looking. How many sticks are in the 6th diagram? And how many thumbtacks on the 7th diagram? Right? Oh, okay. So what I did is I looked at the answers 4, 8, and 12. And we can see that is the diagram for your, you have 4 sticks in your first diagram. So for your figure number 1, you have 4 sticks. So this one here is figure number 1. This here is for figure number 2, and this here is for figure number 3. Right? So we look at the trend, right? You see 4, 8, 12, it is increasing by 4. So your formula for that would be A4 plus n minus 1 by 4, right? You'll get an is 4n. So for your 6th term, it would be 4 by 6, which is 24. So for part 2, B2 would be 24. And part 2, here, B2, that's number of thumbtacks. We use the arithmetic sequence. You know your first term is 4, your difference is 3. So an is 4 plus n minus 1 by 3. That's 4 plus 3n minus 3. Your minus 4 and 3, that's 1 plus 3n. So you know your formula for number of thumbtacks is 1 plus 3n. So if you're finding a 7th diagram, the number of thumbtacks, that's 7 by 3 is 21 plus 1 is 22. Right? So for the 6th diagram, it is 24, and for your 7th diagram, the number of thumbtacks is 22. Right? So for part 1 and part 2 in C, right? Good God. If you look at the rule here, 1 is constant, 3/4 is not constant, 3/4 is also constant, and the last term here is your number of sticks. So if they ask you for 52, right? It's 1 by 3/4 plus 52. Right? And if you multiply this out, you're going to get these answers. So I just multiplied it out in my calculator. I got 40. Right? Right. So when this is equals to 55, I have my formula from above. 3n plus 1 is 55. So I'm trying to find out for n. And when I find out for n, I can find out for s. right? So this is what I did. Number of thumbtacks would be AN is 3n plus 1. I carried across 1, so that's 3n is equals to 54, so n is equals to 18. So for your 18th figure, so when n is equal to 18, the number of sticks, right? We know the number of sticks. We found our formula for number of sticks would be 4 by 18 is 72. And when we know the formula is 72 here, we can do this. It's 1 by 34 by 72, right? And then write in the rule, right? And that's it, right? So guys,